Okay, we're going to take a quick look at two optimization problems, and I think this will do it. I think this will be enough for us enough examples. I want to look at an economics application real quick. I mean economics, it's kind of, sort of, precursor to economics, but has to do with trying to maximize profit in a situation where you've got a bunch of apartments that you're trying to rent. And so you're gonna set the price to try to maximize profit here. So how does this work? It says a real estate office handles 50 apartment units. When the rent is $720 per month, all units are occupied. However, for each $40 increase in rent, one additional unit becomes vacant. Okay. Now let's just stop there for a second. What kind of function does it sound like relates rent to total occupancy? I'm just looking at that for the first two sentences. When the rent is $720 per month, all units are occupied. However, for each increase in rent, each $40 increase in rent, one additional unit becomes vacant.
What does it mean, $40 increase in rent? When would there be an increase in rent?
Well, so like if you raised it, for example, to $760, if you increased it by $40, then instead of renting all 50 apartments, how many would you rent? 49. So if you increased it another 40 up to $800, how many would be occupied? 48 and so on. Okay. So what kind of a function does it sound like? Think about that. What kind of function does it sound like is relating rent price to, call it X, the number of apartment units that are rented? What does this sound like? For each $40 increase in rent, one additional unit becomes vacant. Doesn't that sound like a rate? Doesn't it kind of sound like a rate, right? So what kind of equation do you think is relating those then? If it's got a rate, what kind of equation typically involves a rate? Quadratic? No. What are you thinking? I mean, think back to Algebra 1. What kinds of equations involve rates? Linear, there you go. Right, linear equations. Sure, right? Sounds linear, doesn't it? Right? Okay, so then we've got to come up with that relationship, right? And why do we need that? Well, let's think ahead here. So if we keep reading, it tells us each occupied unit requires an average of $48 per month for service and repairs. So what does that sound like? If we're trying to calculate profit, you guys remember we talked about this a little bit, but it's been a while ago. What's our really simple profit equation? What's profit? What's the definition of profit?
Take home minus expense.
Okay, so say it again. Okay, take home, what do we call that? Like take the money we take in, what do we call that? Well, I mean, it is income, but there's a word for it in economics. No, revenue. So revenue is the amount of money that comes in, and costs are the amount of money that goes out, right? So profit is revenue minus cost. Okay, makes sense? Profit equals revenue minus cost. And it's always that way. Now, defining the revenue function and the cost function, that can be complicated. But what does this part sound like, revenue or cost? Each occupied unit requires an average of $48 per month for service and repairs. That's a cost, isn't it? Right? That's a cost of doing business. The revenue is going to come from what? Think about what would build the revenue function in a situation like this.
Rent times the amount.
Yeah, rent times the amount of, the amount of rent you're charging times the amount of apartments that you're renting, right? Okay, so how do we get that? If we want to focus on revenue, we have to introduce something real quick. This is like lowercase p. That's not an uppercase p. Lowercase p is what we call, and I'm going to call it p of x, is what we call in economics the demand function. How does, like, what, do you guys, have you ever talked about any of this before in any of your classes, like in your personal, do you guys do any kind of a personal finance class or anything like that at some point? You don't do that anymore, huh? Well, you've probably talked or heard about this. What's the relationship between price and demand typically? What happens when the demand for an item goes up? Price tends to go up, right? Does that make sense? If demand falls, then prices tend to fall, right? So the demand function has to do with relating the price of an item to the number of items that are sold, okay? What typically happens when you increase the price of an item? What happens to the number of items that are sold? Usually it goes down. I mean, there's some weird instances where that doesn't happen. Like it turns out in some cases, like you can actually, if you don't charge enough for an item, people think it's not very good and they don't buy it sometimes. But usually, in most cases, when you increase the price, that means that the demand is going to tend to go down a little bit, right? When you're adjusting prices, when you drop the price, you get more competitive and more people would tend to buy it then, right? Okay, so we need to be able to come up with demand, which is the P stands for price. We need to come up with price as a function of x. You already established correctly that it's linear. What is this information telling us here? How could we come up with a linear equation that describes that situation? Just think back to, dealing with in Algebra 1, and we reviewed it in Algebra 2. What do you think? Something like that. How could we come up with, how do we typically come up with a linear equation? How many points does it take to define a line? 2, right? So usually we needed two ordered pairs to come up with the equation of a line, right? How do we do that? Because we have that here, right? We know that we have the ordered pair. What's the ordered pair that corresponds to this statement that when the rent is $720 per month, all 50 units are occupied? Now we're saying price is the output in this case, right? And X is the input. That almost seems a little bit backwards, doesn't it? But that's the way we do a demand function. You're setting the price as a function of demand, actually. So it's a little backwards from the way you'd think about it. My input variable is what in this case? Well, okay, it's X, which would be like 50, for example. And the output is price, which in this case is 720. Right, so we have the ordered pair. This part right here is telling me we have the ordered pair 50, 720, right? And we said if we increase the price by $40, and we picked a specific example already, we said then if we raise the price to $760, what's the corresponding value of X? 49. Okay, so we have another ordered pair at 49, 760. So if I have two ordered pairs, how do we come up with the equation of a line? Okay, so we need a slope, don't we? Yeah, good. So our slope, what would the rise be going from this point, right, where we have an input of 49, output of 760, to the point that has an input of 50 and an output of 720? What's the rise? What's the change in y in this case? Instead of y, though, it's actually p, isn't it? I'm going from 760 to 720? Negative 40. So that's the change in P. What's the change in X? Well, I'm going from 49 to 50. 1, everybody agree? So my slope is negative 40. Okay, doesn't that make sense that it would be negative? Everybody agree? The change in price is inversely related to the change in number of units. So the slope must be negative, right? One's going up, the other one's going down, okay? So we have a slope. We have 2 points. Let's just pick this one because it's got slightly easier numbers. How do we come up with the equation of a line if we have a point and a slope? What form of a line do we use? What would you do? If I know this is my slope and that's a point. Yeah, right. So it's y minus y1 equals m times the quantity x minus x1. What do we call that form of a line? Which one? Point slope formula. Yep. Now for us, we don't have y's, we have p's, right? So for us, we would have something like this. P minus P1 equals m times x minus x1. And the point x1, P1, that's the point, we're saying that's 5720, right? So we get P minus 720 equals m, which is negative 40 times x minus 50. Everybody agree? Give me 1 to 5 on that. Is that all making sense? Okay. So if we distribute the negative 40 and add 720, what's that going to give us then? We get P of x equals so I got to distribute the negative 40, so I get negative, good, negative 40x plus 2,000 plus 720. There you go. Okay, so everybody see, that's my demand function then? That tells me price as a function of input. Okay, and Jaden already told us what revenue is. Revenue is just P, the demand function, the price per apartment times what? Number of apartments, which we call the variable x, right? X is number of apartments, P is price. So then if we want to write our profit function, we're just going to get revenue, which is XP minus cost. And what's cost going to be? Yeah, average of $48 per month for each rented unit. 48x. Everybody agree? That's going to be our cost. Okay, so then let's come down here and let's plug in. We have the value for P, so let's plug that in. Profit as a function of x then is x times P, which is just 2720 minus 40x, if I just put the positive term first, minus 48x. Everybody agree? Okay. Which is equal to 2720x minus 48x. So what's that? 2672? Minus 40x squared. Everybody buy that? Did I do that right? 2720 minus 48, 2700. That seems right, doesn't it? Yeah. Okay, what's our domain? What's our domain? 1 to 50? Probably 0 to 50, right? I mean, and you could charge so much that nobody ever rents any apartment. So it's possible that none of them, that's not a very good idea, obviously. But the possible values of X that you could input into this function that would make sense would be like 0 to 50. Okay? Make sense? My profit's not very good if X is 0, though, is it? Okay. All right, so what do we do? Yeah, this is actually, once we set this thing up, this is a super easy problem, isn't it? Right? All we have to do is just calculus on that thing. And it's a polynomial, so they're easy derivatives. I'm just going to make a table and find the absolute maximum on this closed interval, right? So we differentiate. What's P prime? Do we want to take a second derivative? For sure, super easy. What is the second derivative? Negative 80. So any interior critical number, if the second derivative is always negative, that's going to make it a maximum, right? So if we get any critical numbers, that's going to be our answer, right? Well, we do. When is P prime equal to 0? Yeah, so when 80x equals 2672. So what's x equal to if we do that? Somebody? Who's got a calculator handy or a Chromebook or something? It's going to go in evenly, isn't it? Yeah. Oh, it doesn't? Really? 33.4? That's it? Okay. Okay, 33.4. So, okay. Assume we did that right. I think so. Here, hang on. I'm going to check real quick. I'm going to graph it and see. How do you interpret that? That's going to be, if we made our table, we can make, our table's pretty small. We'll just make it right here. So we get 0 first derivative, horizontal tangent, negative second derivative. What do we do with that? So we go ahead and rent 33.4. That's what we want to do, is pick the price to rent 33.4. Yeah, you can't, right? You can't have partial. Everybody get that? So what do we do? Okay, round down. So, I mean, really, can we just assume because it's, when we round that, it's 33, that that's going to be the one that works? You really can't. You can't. Now, if it were 33.1, I'd buy it. Then you pretty safely could. But when you have a non-linear function like this, do you see that the increase may not be uniform? Like if this were right at 33.5, for example, increasing the input by 0.5 and decreasing the input by 0.5 may not correspond to the same change in the profit. You get that? Because the profit is not linear. It's quadratic, right? And just as a quick example, Like if I were graphing the function, I'll just show you a different example. Like what if we graphed the function y equals x squared? All right, and let's just say this is 1, and that's 1/2. If I scoot to the right from 1/2 by 0.3 or the left of 1/2 by 0.3, you see that that's going to result in different changes in the function because it's curved? Anybody get that? So now do you see why we can't just assume that we could just round here? Give me 1 to 5 on that. Does that make sense? You have a nonlinear function. So what do we have to do instead then probably? We can't just assume that it's going to be 33 because that rounds to 33. Yeah, just test both 33 and 34 and see which one gives us a higher profit. Make sense? Okay. So we would try those. We would plug in 33 and 34 into my profit function and see which one yields a higher profit. Okay, so if we do that, I have the profit function right here, so that's easy to do. P of 33 gives us 44,616. What did I say that was? 44? No, I can't read that. 44,616. So there's that ordered pair. If I plug in 34, what's the word? No good?
We'll have to go to the hospital tomorrow.
Oh, okay. 44,608. So who's the winner? 33. Slightly bigger profit, right? Make sense? So what do we do then? You own the apartment complex. What's that mean? Okay, now I can't directly control the number of people that are renting apartments, but I do have direct control over the price that I charge, right? So where would I go to calculate the price that corresponds to x equaling 33? Yeah, into the demand function, right? That's the function that relates, remember this is lowercase p, right? That's the one that relates price to the number of apartments that are rented. So I would have to plug 33 in for x there, right? And what happens if I do that? If I plug in here, I'm gonna okay, so P of 33 would equal negative 40 times 33 plus 2720. What's that going to give me? 30 times 40 would be negative 1,200 plus another negative, actually what would that be? Yeah, 1,200 plus another 120, right? So 1,320. So what do we charge then? There it is. That's what you charge. 1,400 to maximize your profit. Okay, makes sense? Good, good. Okay, give me 1 to 5 on that. Okay, okay. Might have to look back at that one a little bit. That's a little tougher than the ones you're going to get on the assignment. The ones you get on the assignment, like I'll show you what they look like. So that's kind of what you're looking at, right? Something like that on the homework. A local club is arranging a charter flight to Hawaii. The cost of the trip is $534 each for 85 passengers with a refund of $5 per passenger for each passenger in excess of 85. Find the number of passengers that will maximize the revenue received from the flight. Something like that, okay? So you're doing something similar, right? Probably a little bit easier though. That to me, that seems like that's gonna be a little bit easier. And in this case, they're just trying to maximize revenue for one thing. Makes it a little bit simpler, right? Not profit, just revenue. Okay. All right, so that's that guy. And then the last one I thought would be maybe worth looking at would be something like this. And then I'll shut up with all this stuff and just let you guys work a little bit. So a rectangle is constructed with its base on the x-axis and two of its vertices on the parabola y equals 144 minus x squared. What are the dimensions of the rectangle with maximum area? And then what is that area? Okay, so you guys walk me through this. What should we do? We probably do, yeah. Remember, step one, think about the steps on this. What are we doing when we're solving an optimization problem? What are we always trying to do first? Well, yeah, okay, and actually the objective function comes up in step two. Step one is sometimes you can, sometimes you can't. But what are we always trying to do in step one? Find our variables and, draw a picture if you can. That's super helpful. So here we could, right? This is a function, so this is a really easy one to draw a picture for. Does it have to be exact? No, we just need to orient ourselves and figure out what's going on. So what does that look like? Y equals 144 minus x squared. Upside down parabola, good. Describe that. Where are the x-intercepts? 12 and negative 12. And so the vertex must be when x equals, if the x-intercepts are at negative 12 and positive 12, where's the axis of symmetry going to be? 0, right? X equals 0. It's got to be halfway in between. It's symmetrical, right? So the vertex, what are the coordinates of the vertex going to be? 0, 144, right? If I plug 0 in for x, I get 144 for y. Okay? So our picture then just looks like, we're not going to draw it to scale or anything, but it just looks like this. That's at negative 12, that's at positive 12. The height of this thing is over here at, we'll just make that point, 0, 144 at the vertex, right? Okay, what are we trying to do? We're trying to build the rectangle with its base on the x-axis that's going to maximize area. So something like that, right? Agreed? Talk to me. What are we going to do? So what's our objective function going to be here? Area, right? Area is what we're trying to maximize. Okay. What's the area of a rectangle? In general, what's the area of a rectangle? Length times width, or in this case, maybe like base times height or something like that, right? The horizontal dimension times the vertical dimension. Well, how's that work? Like, what's that going to look like? What's the height going to be? What, call it y. Okay, this point right here, what are the coordinates of that random variable point? X, y. So the height is y then, right? What's the width of the rectangle going to be? No? 2x. How come? Yeah, there's both sides, right? This point right here has coordinates negative x, y. And so the whole width of this thing is, if that distance is x, well, it's 2x. Everybody agree? Okay. Okay, what's wrong with our objective function? Two variables. So we need some equation of constraint. Now, what's the constraint here? Has to be on the parabola, right? So if the parabola is the constraint, well, can you guys tell me what's my secondary equation? Yeah, there it is, right there, isn't it? Here's my secondary equation. And it makes sense because that's the constraint. That's what the rectangle is bumping up against. If without that parabola, we would just make it infinitely big, right? But you can't because it's constrained by the parabola. So then if we plug that in for, and that's going to be my substitution, isn't it? We'll just substitute for y. So then we get area as a function of x equals 2x times y, which is the quantity 144 minus x squared. Okay? So what would our domain be here? What would it be? Negative 12 to 12 are that's the domain of x. And people, let's vote with our thumbs. How many people will agree with that? Anybody disagree? What do we think? Right, those are just, I agree. Those are where, if you look at the kind of the short wide extreme of that rectangle, it would have no height and a width of 24 or something, right? But now remember the domain, those are the values of the variable x that are valid. Is it 0 to 24? What do you think? Where do you see x on this? I see an x right there. That's not x, that's negative x, that point, right? As this point gets dragged down, what's the biggest value? What is it? 0 to 12. Everybody see why? If I drag these points right here all the way down and make this thing as wide as possible, the biggest possible value of x would be 12. Everybody agree? If I drag this thing back up and make it taller and skinnier, what's going to be the smallest possible value of x? 0, right? Everybody agree? If x is 0, what would y be? 144. If x is 12, what would y be? That makes sense, doesn't it? Those are the two. Now, those are not going to be the winners, right? Because in both of those cases, we get no area, but those are the those are the boundaries of x that would make sense, right? That's my domain. Okay, give me 1 to 5 on that. Does that make sense? Okay. Everybody see why it's not negative 12 to 12? Right? Okay. And again, what do you find? That's really easy, right? That's the easiest possible kind you can deal with. When I distribute that 2x, I just get another polynomial, and those are the easiest ones to differentiate, and the equations are easy to solve, right? You don't have to do anything complicated at all. So what would I do to wrap this up? We're almost done. Distribute the 2x, good. So we get, if we write this as a polynomial, a of x would be what, 288 x minus 2x cubed. Now what? Take the derivative. What's a prime? 6 x squared. Would I take a second derivative? Yeah, definitely. It's easy to do. And I just get what? Negative 12x. Okay, and so for any positive values of x, what's the sign of the second derivative going to be? Negative. Okay, so that's going to give me maximum, isn't it? Right, that's going to be concave down. So what do we need to do to get our critical number? Okay, I'm hearing it. So a prime equals 0 when 6x squared equals 288. So if I divide by 6, what do I get? What is that, 48? Is that right? $24, yeah, is that right? Yeah. 24, yeah, that's right. Okay, so then x equals? What's that roughly equal to? 6.92. Okay, and I don't need the negative one because that's out of my domain. And that's going to give me a negative second derivative. And so my table looks pretty easy. We had at roughly 6.9, we had a 0 first derivative and a negative second derivative. So there it is. And then for the second part of this, so they want the dimensions. Well, that's x. How would I find y? Yeah, plug it in, right? And then now you got to be careful on these because sometimes people get all the way to the finish line and they make a dumb mistake. What would the width be of the rectangle? Say it again. No. 2 times x, right? That makes sense. And I plug that in and get the height. And then the second part is, what is the area? All I got to do is plug it into, I already have that function. Just plug x in, right? Everybody good? Okay. I'm done. You guys can work tomorrow.